Hello, Kirtan. As you know, this week we have solved a lot of exercises regarding our lesson, which is polynomials function and continuous function. Okay, so I'm going to solve an exercise which is similar to those we have solved in class that covers all the needed objectives. First of all, we have here this function, which is minus x minus 5 plus x over x squared plus 4. This is a rational function, okay, that we need to study its variation. In order to study the variation, of course, we are going to pass it through a lot of important steps. First of all, the domain of definition of this function is R. So when calculating the limit at x tends to minus infinity and limit at x tends to plus infinity, at minus infinity, as you can see, we will get plus infinity. And at minus infinity, also we replace, we're going to have minus infinity. At minus infinity, plus infinity, and at plus infinity, minus infinity. After that, we're going to prove that the equation y equal minus x minus 5 is an asymptote to C. How do we prove an oblique asymptote? First of all, we're going to find f of x minus y. After finding f of x minus y, we need to do the limit when x tends to plus infinity or minus infinity. We should get 0. So we did f of x minus y, we get x over x squared plus 4. When we do the limit when x tends to minus infinity, the first time we will take the highest over the highest, we simplify, and then we replace 1 over infinity is 0. Now, we need to find what? I'm going to go back to the question. We're going to find the intersection point of the curve with this oblique asymptote. In order to find the point of intersection of any two lines or between a curve and a line, we need to do y equals y. So we do f of x equals to y, okay, which is x over x squared plus 4. We put it equal to 0, and then we get x equal to 0. After finding x, we replace it with the original function, so we get f of 0 equals minus 5. So the point of intersection between the curve and the oblique asymptote is 0, minus 5. Let us now continue. Okay, so what's the second question here? We need to determine x so that C is above D. So this is a relative position between the curve and the line D. What I'm going to do is, we study as if we are doing the relative position. If C is above D, then f of x is greater than y. So we solve it, f of x greater than y, we get x over x squared plus 4. You know that x squared plus 4 is positive for every x. So x should be positive in order to have a positive value. So x is greater than 0. So what's x? X will be greater than 0. Now, in part E, we need to prove that I, which is 0 minus 5, is the center of symmetry of C. What's the rule to prove center of symmetry? F of 2a minus x plus f of x equals to 2b. So f of 2a minus x, which is f of minus x, plus f of x should get minus 10. So you replace in this form. Every time you see x, you're going to replace it by minus x. So you get minus 10 equals minus 10, as you can see. Now, after finding the center of symmetry, we need to find the derivative, do study sign, draw the table of variation. So the derivative of this function, you do the derivative of minus x alone, minus 5 alone, and this fraction alone. The derivative of minus x is minus 1, the derivative of minus 5 is 0, and now we need to do the derivative of this fraction, which is u prime v minus v prime u over v squared. When you do this, you need to do a common denominator, okay? So this is our function. Now we need to study sign. The denominator is always positive, and the numerator is always negative for every x. So then the derivative is negative for every x, then the function is strictly decreasing. So if you want to draw the table of variation, it will be in this way. So this is a continuous function, which is decreasing from plus infinity to minus infinity. Now we need to calculate the equation of the tangent f of x, or at the point 0 minus 5. What's the equation of the tangent? Y equals f prime of a into x minus a plus f of a. So the equation of the tangent is minus 3 over 4x minus 5. Now the last part, which is the most important one, show that the equation of x admits a unique solution alpha such that alpha is between minus 5.2 and minus 5.1. Every time you see the word unique solution, means that this function is either, of course it's continuous, it's either strictly increasing or strictly decreasing. So according to our equation or our function, it's strictly decreasing. So how do I answer? We say that f is continuous on R and strictly decreasing. We calculate f of minus 5.2. One of them should be less than 0 and the other should be greater than 0. Since it's decreasing, then the first one is greater than 0 and the second one is less than 0. Now we're going to draw. I always advise you to plot the alpha on the curve. You have to plot that alpha is here, for example, and then you draw the curve with the tangent and the oblique asymptote. Okay, so this is the function. It's decreasing and it passes through the center of symmetry. I wish that this is clear. Of course, you can go back to your worksheet. You need to solve it again. The solution is found in the application. And if you have any question, of course, you can go back to the previous lecture where I explained every objective. And of course, our exam will be similar to such questions I've already solved.